Hi there, this is Ms. Page. In this lesson, we're going to talk about how to find the surface area of cones, specifically right cones. So one of the things that we will need to use from our prior learning is area of a circle. So we need to remember the formula for area of a circle is pi r squared, r being the radius, and when necessary to find the radius, such as from the diameter as shown here. And we know that the 6 centimeters is our diameter because it goes all the way across the circle through its center. And so remember the radius is half of the diameter, and then plugging that into pi r squared for area. Another piece of prior knowledge that we need for these problems many times is our Pythagorean theorem. And you might be wondering how right triangles are connected to cones, and we are going to talk about that, but we do have some situations in which we have right triangles and have to use our Pythagorean theorem. So Pythagorean theorem, remember that the side opposite our right angle is our hypotenuse, which we refer to as C, and the other two sides are our legs, A and B. One of the things that in context problems we need to be careful of is making sure before we use our Pythagorean theorem that our units match. So here we're supposed to find the side of the missing triangle, but we want it to be to the nearest tenth of a foot. So we actually want this to be in feet. So we have to first convert our 36 inches into the units of feet, and that's what's shown here, giving us 3 feet. Then and only then will our Pythagorean theorem give us a correct answer in this situation. So we have our a squared plus b squared equals c squared, which in feet gives us 3 squared plus 6 squared equals our hypotenuse squared, and then the square root of that 45, which is a 6.7 or actually about, so that should technically be a little squiggly there, and so we can get the missing side. All right. So the idea of finding surface area of a cone, where we use S in these formulas for surface area. And so when we look at a cone, flattening it out, say in the terms of a net, we get 2 pieces. We get the base of the cone, which is a circle. So we have area of a circle, which is our capital B for base area, and that then becomes pi r squared. And then we have the side of the cone, which is kind of interesting. When you flatten it out, so you cut down the side of a cone, separate it from its square base, and then flatten it out, you get this type of a shape here. And this type of a shape is what we call a sector. So the sector, they're showing the whole circle, but the sector is this part here. And that, if we folded and connected it, would give us the side of a cone. So remember, here's our circular base, so it gives us that side that wraps around the circle. And when we find the area of a sector, the mathematical formula for calculating it is shown here. So this is also our lateral area L, the side or sector, and it's pi r L, where L, remember, is the slant height of the cone. This L, the cursive L, is the slant height of the cone. It goes down from the apex to the circumference of the circle, like so. All right. So that means that to find the surface area of a cone, the 2 measurements that we need, or 2 dimensions that we need, are the radius and the slant height, L. And then we can either find the pieces separately and add them together, or most of the time I just recommend putting it all together into your calculator to get the most accurate answer and to usually speed up the process of the calculation. If we are finding just the slant or the side of the cone, then remember that would be just lateral area, and we would only use our pi r L, which represents that lateral area, capital L. All right. Let's take a look at this problem here. So here it says a company packages popcorn in containers that are in the shape of a right cone. Each container will be wrapped completely in cellophane, side and top, in case we were uncertain. It gave us some clarity there. Estimate the amount of cellophane needed to wrap each container. round to the nearest tenth of a square centimeter. So we want side and top, so that's total surface area. We want to the nearest tenth of a square centimeter, so we want to make sure all of our measurements are in centimeters, which they are. We have centimeters here and here. And then we can go ahead and start looking at the calculation for that total surface area. So remember that for total surface area, lateral area plus base area, that our lateral area is pi RL, that's our sector, and our base is our circle, so that area is pi r squared. So that means we need radius r, and so we would identify that as this segment here. The arrow is pointing to a segment that goes from the center of the circle to its circumference, so that 12 centimeters is our r. But the lateral height, or the slant height, is cursive L, and we have to be careful that we understand that it goes from the apex slanting to the outside edge or circumference of the circle, and we don't know what that is. We actually have to calculate it. So here's one of those situations where we're going to have to use our Pythagorean theorem. So our Pythagorean theorem in our cones, here's our right triangle. It involves our radius r, our slant height L, and the 16 centimeters perpendicular from apex to base. That's our height of our cone h, which we actually use in a volume calculation. So the Pythagorean theorem for a cone always actually is the radius squared plus the height squared equals the slant height squared. Our radius here, remember, is 12 centimeters, so we get 12 squared. Our height h is 16, so we get 16 squared equals L squared. Personally, I would recommend that you just take the square root and speed up this process and do the square root of 12 squared plus 16 squared in your calculator. But if you want to do piece by piece, you of course can. Notice we want our surface area to be rounded to the nearest tenth. So again, if I'm going to use a decimal approximation here, I would carry it out a couple extra places for accuracy at the end to make sure my final answer is as accurate as possible. And so I'm going to carry this out to at least 3 decimal places. Let's see what we get. So sometimes, as in this case, we plan for rounding and then it's not necessary because we actually get an exact value of 20 here. And the units on this 20 would be the same as the units on the 12 and the 16, which would be centimeters. All right, so now we have our slant height L, we have our radius R, so we're ready to calculate the surface area in this case. So we have our surface area would be pi times our radius of 12 centimeters times our slant height of 20 centimeters plus the area of our circular base, which would be pi times our radius of 12 centimeters squared. So again, I would recommend you do this all at once in your calculator. You're going to have centimeters times centimeters here, which gives you centimeters squared, plus, remember you're squaring the 12 and the centimeters, so that's centimeters squared. So we're going to get centimeters squared as we would need and expect in this situation. So let's use our calculator now. All right, so if you are doing the calculation with me, hopefully you are coming up with the same number I am. And so again, remember we were rounding to the nearest tenth at this point, and we should be getting 1,206.4 square centimeters. So now we would be able to, or be ready to, write our conclusion. So let's go back and take a look at what this was about again. So what does this represent? So we are estimating the amount of cellophane needed to wrap each popcorn container. All right, so that is going to then give us as our conclusion. So to wrap each popcorn container, about 1,206.4 square centimeters of cellophane is needed. If you've never heard of cellophane before, I am sure that you have seen it on things. It is that clear plastic wrapping that's kind of crinkly, usually used a lot on gift baskets and things like that. All right, so let's move on to what's next. All right, let's look at this example here. So here it said that Shelley plans to make 8 conical party hats for her niece's birthday party. So conical is an adjective to describe things that are shaped as cones, in this case party hats. She wants each hat to be 18 inches tall and the bases of each to be 9 inches in diameter. How much material will she use to make the hats? And we're supposed to give an estimate to the nearest square inch. So, all right. Here, I'm going to make myself a diagram here of a cone. So I made just kind of like a upside down V shape, and then I'm going to curve like here for my circular base. All right, so what do we know? We know that each hat is to be 18 inches tall. When we talk about how tall something is, we are talking about its perpendicular height to, say, the bottom or the ground, in this case, the base. So that means from the apex straight down, perpendicular to the base, that is how tall each hat is, 18 inches. It also says that she wants to make the bases of each 9 inches in diameter, which means that we're talking about this entire length here going across. That's our diameter D of 9 inches. All right, so we want to know how much material she will use to make the hats. Now, one of the things you have to realize from the context of this problem is that she's not going to use material to make the circles, because if we're going to put those hats on the top of people's heads, then we need it to be open so that it will actually sit on top of somebody's head. So this is actually just a lateral area problem, L, which remember is calculated as a sector pi r L. So we need our slant height and our radius still, but we are only doing this calculation here for the side of each cone. So radius, got to be careful here. Realize that your radius is half of your diameter, so our radius would be half of this 9 inches, which would be 4.5 inches. So got that part done. Got to be super careful with your slant height L, because remember 18 inches is our height H. Slant height would be here, and we're going to have to use our Pythagorean theorem. What can be tricky about this is for people who don't stop and think about where that right triangle really is. Remember that that piece is not the diameter. That piece is the radius R. So when we go to find our slant height, so we found our radius, so now we need our slant height, and it is going to be using our Pythagorean theorem, where we have our radius squared plus our height h squared equals our slant height squared. And so we get 4.5 squared for our radius squared plus our 18 squared will equal our slant height squared. Again, I would just recommend here taking the square root of both sides, so your L is going to be the square root of the 4.5 squared plus 18 squared, and doing this in your calculator all at once. Again, if it turns out I need to round, I'm going to carry it out a little bit further. So this is nearest square inch, which we should understand means to the ones place, or nearest whole number. So I would carry this out 2 or 3 decimal places to help with my accuracy at the end of my problem. All right, let's use a calculator. All right, so carrying this measurement out to, say, the hundredths place, 2 decimal places. Hopefully you're in agreement with me of 18.55, and the units would be the same as the units on our radius and our height h, which are both in inches. So this would be inches. All right, so now we are ready to calculate that surface area. And here's again where it's important to be paying attention to all parts of the problem, where annotation is super helpful. So one thing I purposely did not highlight earlier on, because I wanted to kind of point this out to you in case you have forgotten about this part of the problem, it says Shelley plans to make 8 party hats. And we want to know how much material she needs to make the hats, plural, all of the hats, which means that when we go to calculate the total amount of material, we still use our surface area here, but we need to multiply that times 8, so we get a total for all 8 hats. And I would do that again all at once. So when I go to find my surface area, I would take 8 times pi for my 8 hats times my radius of 4.5 inches times my slant height L of 18.55 inches. All right, so now using my calculator again. So here, hopefully you are in agreement with me. This would be to remember the nearest square inch, so the ones place or nearest whole number. So here we would get about 2,098 square inches. And now we can write our conclusion. So again, this is the material that Shelley will need or be using to make the hats. So I'm going to say Shelley will use about 2,098 square inches of material to make the hats. And you might even want to be more specific and say to make the 8 hats. All right, let's move on to what is next. So here is a practice problem. So I recommend that you pause the video here, try this problem, and then come back when you're ready to check your answer. Let's take a look at the results for this one. So this one kind of broken down here a little bit. So you have to, given this, you know that each tent is 5 feet tall. That's your H, with a diameter of 7 feet. So half of that 7 is our radius, which is 3.5 feet. Your slant height L, again, set up here with our right triangle. So we have that R squared plus H squared would equal that slant height squared. And that is shown here. And that is 6.1 feet. And then we want a total surface area, because notice it says he's going to cover the side and the base or bottom of the tent. Don't want to sleep on the dirt. And so we get pi r L plus pi r squared, and rounding to the nearest tenth, about 105.6 square feet. All right, moving on. Second practice problem, so please pause your video here and come back when you're ready to check your answer. Let's take a look at this one. So again here, given the diagram, it shows the 6 feet goes all the way across the bottom of that cone roof. So that means our radius is half of that 6, which is 3 feet. Here, we should realize from the context, hopefully you realize from the context, that the roofing material to cover the roof is only going on the outside of the side. It's not going to go on that bottom, because that bottom is actually on the inside of that little turret there. And so we're just doing lateral area. And the 12 is our slant height, because it goes from our apex down to the outside of our circular base. And so just plugging in your 3 and your 12, multiplying by pi and rounding the nearest square foot, you've got about 113 square feet of roofing material needed. All right, moving on. Third practice problem here. So again, pause your video. Let's take a look now at the result. Okay, so here, hopefully, we've talked about this in other lessons. That 16 inches is pointing to a segment that goes all the way across the middle of the circle. So that is your diameter D, which makes your radius half of that 16, or 8 inches. You have to then remember that 2 in this problem, your right triangle again, uses your radius and your height here, h, of 15 inches. So you've got r squared plus h squared equals your slant height squared. So you have to use the 8 there, not the 16. And so you get a slant height of 17 inches. And then here, in this particular problem, the lateral surface is going to be covered with paper. And so we're just doing a lateral area, pi r L. And we want to cover each candle. And let's see, did we have just one candle? Looks like we had just one candle here. So there's our calculation, and rounded to the nearest tenth in square inches. All right, so that finishes up this lesson. I hope you have a great day.